ago, the voltmeter portion of that Acopian power supply was not working. Now, the power supply uses 1 meter, and that meter is basically a 1 milliamp full-scale meter movement, as a voltmeter to measure voltage, and as an amp meter to measure current. And these configurations are switched by a front panel switch. In the voltmeter, we have a series resistor, and it's designed such that it allows 1 milliamp to flow when the meter is deflected full scale. In the ammeter configuration, there's a shunt resistor so that, let's say, for example, it was 1 amp full scale. 1/1000th of that current would flow through the meter, and 999 thousandths would flow through the shunt resistor. The first thing I'm going to do is see if the meter is accurate in the amp meter configuration. If it reads half as much as it should, then the basic meter movement is suspect. I've got the power supply hooked to the load resistor bank, and I've got it set up with 1 4-ohm resistor. So I'll turn the load on. It's going to get a bit noisy. Then I'll turn on the power supply. You see, the maximum voltage I can get is 4 volts. It doesn't look like any current's registering at all. According to this, I've got 8 volts and 2 amps. So we got a problem with the meter. The shunt resistor is apparently still working. After all, this has to be in series inside the supply with this. So the 2 amps is flowing through here, not causing any meter movement. Well, that's interesting. So both of these display meters are the same. They both inside below the scale. At the bottom of the scale, they read 1 milliamp full scale. So they're using the same meter movement and putting different scales on them and using different series and shunt resistors to match whatever scale is installed. Now, I've got the bench meter hooked to ohms. I go to the basic meter movement down here, and right across the meter movement, I read 550 ohms. Across this meter movement, I read 88.6. And my ohm meter is actually causing a deflection. Let's see what it's doing here. I reverse the meter leads, and the meter reads full scale. Go back to here. The meter reads nothing, and the ohm meter reads 500 and some ohms. So I suspect we have a bad meter movement rather than a bad set of series and shunt resistors. So what we have here is a meter secured with a big nut. So just out of curiosity, I'm measuring the, using my bench meter, I'm measuring the resistance of this microammeter. And I'm reading 100 ohms, and this thing says almost 1 milliamp is flowing, which would explain why the responding meter on the power supply went to full scale when I put this meter across it. Just a sanity check. So, well, it appears that this meter is defective. No movement. Now, these aren't made to be repaired, of course. But if it's no good, we might as well look into it. And let me make this a clean room. Okay. At this point, we can open the meter up. I don't know if the scale is glued or, well, it is. Yep, it's glued. At this point, if this were a little higher quality meter, the scale would be fastened on with screws, and I wouldn't be in danger of ruining the meter. Because if I lift too quickly, I'll damage the meter movement. All right. After a lot of screwing around, see what connecting the meter does? Causes it to deflect. Full scale. So I don't know what happened. I don't know if it's dependable enough to put back in. So I decided to solder the wire onto the connector. Now what I'm going to do is ever so gently push the meter full scale and then hold it there with the clip while I put it back together. So with the needle held over with this clip. I'm not fastened to the needle, I'm just holding it full scale, or nearly full scale. Well, I'm going to try to stick the meter back in and see if I can get anything to work. So I still have the bottom open. I'm not used to working on something where all the components hang from the top. Maybe a little bit too much glare. There we go. But you can see it's zeroed. Power's off. Turn it on. And there we go. Doesn't quite go to 8. And look what it does do. It goes negative. So I'm wondering if something needs calibrated. In any event, I'll put a load on it and I'll compare this meter with either a bench meter or a multimeter laying on the bench. This is a setup I'm going to use to verify that this works. Be noisy, but when I turn this on, you'll be able to read volts and amps. I also have off camera a bench meter hooked up here. Now, interesting enough, when I turn this down, I do go below 0. And if there's no load, I can actually turn it down more than a ½ a volt reverse polarity. Without a load, I'll set this at 5 volts using my bench meter. My bench meter says 5.0173. This meter is obviously a little bit low. And this meter looks to be pretty good. With a 4 ohm internal resistor, that looks like a good current reading. The most I can get out of this right now it's putting out a little more than 8 volts at about 2 amps. That's 3.0300, and that's as good as an analog meter gets. So here we are at 5 volts, 1.2 amps more or less. You see this meter now is reading a little low on current. Five volts, that looks good. Should be up at this major division 1.2, and it seems low. So I'm going to proclaim this side of the supply as working. I hope you enjoyed this video. Thumbs up. Drop me a comment or subscribe to my site. Thank you.